Hello and welcome all my grade 9 elite and 10 advanced math students to my session on tests for parallelogram lesson 2.3. Let's get started with the session. This is Ms. Ruchika welcoming all of you to today's session. And our today's goals would be to use the test for parallelograms to determine whether quadrilaterals are parallelogram. So in today's session, you will be looking at some theorems and some tests for parallelograms, which will be used to prove that a given quadrilateral becomes a parallelogram. So let's go through them one by one. If a quadrilateral has each pair of opposite sides parallel, then it's a parallelogram by definition. This you already know. This comes from the definition of parallelogram. This is not only for the test, however, can be used to determine if a quadrilateral is a parallelogram. So this leads to four theorem, number 1, number 2, number 3 and number 4 that we'll be doing today. The first condition or the first theorem or the test is if both pair of opposite sides of quadrilateral are congruent. Congruent means they have same or equal measure, then the quadrilateral becomes a parallelogram. So if the opposite sides are congruent, then the quadrilateral becomes a parallelogram. That's one test. If the opposite angles of a quadrilateral are congruent, then also it becomes a parallelogram. That's another condition. Next one, if the diagonals of a quadrilateral bisect each other. Bisect each other means they're divided into two equal parts. Then also it becomes a parallelogram. And finally, last one, if one pair of opposite sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. So these four tests we will be using in today's session to prove that the given quadrilateral is a parallelogram. So let's look at the first question and see which theorem is going to apply here. So you are given all four sides of the parallelogram. Look at the quadrilateral. So determine whether this quadrilateral is a parallelogram. Justify your answer. So very easy to spot that the opposite sides are equal and they are parallel, which makes it a parallelogram. So if both pairs of opposite sides are congruent, then the quadrilateral becomes a parallelogram. This theorem we have used. Opposite sides are congruent or they have same measure. This is 12, this is 12, this is 5, this is 5. Then the quadrilateral becomes a parallelogram. Easy question. Let's look at the other one. Here the angles are given to you if you see. So this angle is 56, this angle is 7x, this angle is 5y minus 26 and this is 4y plus 4. So this is a parallelogram given to you. It appears to be a parallelogram as you see. That's the top of an eraser. Find the values of x and y so that the side of the eraser is a parallelogram. So you have to say that this is a parallelogram. So when it is a parallelogram, we can say both pairs of opposite angles are congruent. That means 5x 56 will be equal to 7x. Divide by 7, x is equal to 8, and this angle, opposite angle, 4y plus 4 is going to be equal to 5y minus 26. So solve it. Take the 26 on the other side. 26 plus 4 gives you 30. This is equal to 5y minus 4y. So y is 30. So you have got your x and y so that you can find all the angles. So that's what you see here. X is 8 and y is 30. So when x is 8 and y is 30, the quadrilateral is becoming a parallelogram because that is when the opposite angles are congruent. Let's solve this question now. The mosaic of the pattern of the floor is made up of different tiles. Now this tile looks like a parallelogram. I'm going to highlight the tile with yellow color. So this one, the side length is 3x plus 4. This one, the side length is 5x minus 2. Now because it is looking like a parallelogram, these two sides have to be congruent or equal. And similarly, the other two I'm doing with blue, 4y minus 9 and 2y plus 5. These are going to be congruent as well. So they are going to be equal. So let's solve it. 3x plus 4 is equal to 5x minus 2. Opposite sides of a parallelogram are congruent. That's the theorem we are using. So I take the 2 on the other side, it becomes plus 2. I take 3x on the other side, it becomes minus 3x. So this is 2x equal to 6. Divide by 2, you get x as 3. Okay, let's find y for the opposite sides, these two. 2y plus 5 is equal to 4y minus 9. Solve for y. Take the 2y here, becomes negative. 5 plus 9. So this is 14 is equal to 2y, or y is 7. So you have got your answers. X is 3, y is 7. So which theorem did we use? We used the theorem that if both pair of opposite sides are congruent, the quadrilateral is a parallelogram. We looked at the opposite sides, not the angle, so this is not true. We did not look at the diagonal, so this is not true. And we did not take only one pair of opposite sides equal and parallel, so this is not true. And first is the correct one, where we took both pairs of opposite sides congruent or same or equal, and we said that the quadrilateral is a parallelogram. So that's the theorem you will select. Now, sometimes your distance, slope, and midpoint formula from coordinate geometry helps you in solving problems on parallelogram. So these three are very important. I hope you remember them, and we are going to use them in the questions on coordinate plane or coordinate geometry. So identify parallelograms on the coordinate plane. How do you identify this question? You are given the xy plane. So you can see the squares. So this is what is called coordinate plane. So when such a plane is given to you, your parallelogram or quadrilateral is given on this x and y plane, you know the question will use either the distance or the slope or the midpoint formula. So let's see here which one we are using. In the question itself, it is mentioned use midpoint formula. So we are going to use that. Determine whether quadrilateral FGHJ is a parallelogram. Justify your answer using midpoint formula. Now midpoint formula means the middle point, means the bisection. So that helps you to know that we are going to use this theorem. Which theorem? If the diagonals bisect each other, then the quadrilateral is a parallelogram. So we have to find the midpoint of the diagonals. Now, if I draw roughly the diagonals, the diagonal will be the non-consecutive vertices, so FH and JG. So this is the point where the diagonals meet roughly. Okay, now you have to find the midpoint of FH and the midpoint of GJ, so that you can check if it is same, the diagonals bisect each other. If it is different, the diagonals don't bisect each other. Now in order to apply midpoint formula, we need the coordinate. Let's see the coordinate. For G, the x coordinate is 1, 2, 3, 4, and y coordinate is 2. So this point is 4, 2. This point is minus 2, 1, 2, 3, 4. This point is 1, 2, minus 2, y is minus 1, and h is 4, minus 2. So let's calculate from these 4 points the midpoint of the same. Now midpoint is equal to x comma y, where x is the x coordinate added divided by 2, y coordinate is y1 plus y2 added divided by 2. So let's use it. Okay, so the midpoint m of Gj using midpoint formula comes out to be 1 comma minus 1 by 2, and the midpoint of Fh, the diagonal, comes out to be this. Now these two are different, they are not same. So if the diagonals bisect each other, then it is a parallelogram. We are using this theorem, and in order to use this theorem, we should have the same midpoint. But because the midpoints are different, they do not have the same coordinates. Can we say it is a parallelogram? No, not at all. So quadrilateral FGHJ is not a parallelogram because the middle point is different, so the diagonals do not bisect each other, so it cannot be a parallelogram. So the test for parallelogram fails in this question. Now let's do the check question together. For that we need the coordinates of A, B, C, D. A is 1, 2, 3, 1, 2, 3, 3, comma 3. B is 1, 2, 3, 4, 5, 6, 7, 8, 8, comma 2. C is 1, 2, 3, 4, 5, 6, 6, comma minus 1. And D is 1 comma 0. Now the diagonals are going to be roughly like this. I'm drawing the diagonals. So we have to look at the midpoint of AC and the midpoint of this one. So midpoint of AC is equal to x equal to x1 plus x2 by 2, and for y it is y1 plus y2 by 2. So 3 plus 6 by 2 and 3 minus 1 by 2. So the middle point is 3 plus 6, 9 by 2, which is 4.5, and 2 by 2, which is 1. So this is the midpoint, say M of AC. Now we'll calculate midpoint of BD, which is equal to 8 plus 1 by 2 and 2 plus 0 by 2. So this is coming out to be 9 by 2 comma 2 by 2, which is 4.5 comma 1. Now look at the midpoint. The midpoint here is this, the midpoint here is this. So since the midpoint is same, midpoint of AC is equal to the midpoint of BD. That means the diagonals bisect each other. And when diagonals bisect each other, the quadrilateral becomes a parallelogram. Therefore, ABCD is a parallelogram. Because a test for parallelogram is true, the diagonals bisect each other, the midpoint is same, so this is going to be a parallelogram. Let's look at these questions. Very easy direct questions. Here you see these opposite sides are parallel also and they are equal also. So therefore it is going to be a parallelogram. That's the theorem that we apply, that opposite side, one pair of opposite side is equal and parallel. Look here, the opposite angles are congruent. So this is also a parallelogram because both pairs of opposite angles are congruent. Look at question 3 and question 4. In question 3, one pair of opposite angle is equal. So it is not a parallelogram because the condition is not true. In question 4, both the pairs of opposite sides are equal. So they are parallelogram. Look at question 5. The diagonals bisect each other. So yes, it is going to be a parallelogram. Look at the next one. One pair is parallel, one pair is equal. So no, it is not a parallelogram because none of the condition is true. Now let's solve this question. It's like a word problem. The space between the hinges and trays of a collapsible tray organizer appears to be a parallelogram. I hope you can see the parallelogram here. 1, 2, 3, 4. So it looks like a parallelogram, and the values of x and y so that the trays and hinges form a parallelogram. So when will this quadrilateral form a parallelogram? When opposite angles are equal. So this is equal to this and this is equal to this. So 3x plus, okay, sorry, 3x minus 4 is equal to 2x plus 16. So this one is equal to this one and this one is equal to this one. So this is true, and 4y minus 56 is equal to 2y plus 34. This is true. So when these two conditions are satisfied, that's when you get a parallelogram. So let's solve. 3x, I move this here, minus 2x, I move the 4 here, 16 plus 4. This is 20. So x is 20. You've got the value of x. Let's find y. I'm going to move the numbers here. So 4y minus 2y is 56 plus 34. So this is going to be 90. 2y is 90. So y is 90 divided by 2, which is 45. So what is the value of your x and y? That makes it a parallelogram. X is 20 degrees angle, y is 45 degrees angle. So that's your answer. Another one very similar, you can solve it yourself. I will just give you a hint. This is a parallelogram. As you can see, you have to find the value of x and y so that the quadrilateral becomes a parallelogram in this design. So this side is equal to this side and this side is equal to this side. So 2y plus 3 is equal to 4y minus 7. Opposite sides are equal. And 6x plus 1 is equal to 8x minus 3. Again, opposite sides are equal. Solve it for x and y. So this goes here. 3 plus 7. So 10 is 2y or y is 5. Similarly, solve for x. 8x minus 6x. That's going to give you a 2x. 1 plus 3 is going to give you a 4. So x is 2. So x is 2, y is 5. This is how you solve the question on parallelogram. Another one where you know that the diagonals bisect each other. Find the values of x and y so that the quadrilateral is a parallelogram. So this length and this length will be equal. This length and this length will be equal. So minus 4x minus 2 has to be equal to minus 3x plus 4. And 3y minus 5 has to be equal to 2y plus 18. Now I want you to solve this question and this question together. I'm leaving you with the equation. Let me know in the comment section what is the value of x and y for question 9 and question 10. In question 10, the opposite angles will become equal. So the equation would be 5x plus 29 is equal to 7x minus 11. And this angle will become equal to this angle. So 3y plus 15 is going to be equal to 5y minus 9 degrees. So find your x and y from here and let me know in the comment section what is your answer. Okay, so we can also use the slope formula to determine whether the ABCD is a parallelogram or not. Let's see how we do that. So here in the coordinate plane, you are given the coordinates of the four corners or the vertices of the parallelogram. So you can number A, B, C, D as A equal to x equal to minus 2, y equal to 3, B is x equal to 3, y equal to 2, C is x equal to 2.5, y equal to 1 minus 1, D is x equal to minus 3, y is 0. So here you can find the slope. Let's do it. And then from the slope, you can easily calculate. Here, this is 2, I'm sorry, 2.0. So this is 2. So you can now calculate the slope of the opposite sides. So when you use the slope formula, m equal to y2 minus y1 over x2 minus x1, the slope of AD comes out to be 3. AD, this slope is 3. For slope of BC is also 3. The slope of AB is minus 1 by 5 and the slope of CD is minus 1 by 5. So the opposite slopes are equal. So when opposite slopes are equal, these sides are parallel. So because the opposite sides have the same slope, AB is parallel to CD and AD is parallel to this. So remember, parallel lines have same slope. This is the concept we have used here. So when the slope came out to be equal, we say they are parallel. So AD is parallel to BC and AB is parallel to CD. So opposite sides, two pairs of opposite sides are parallel, then it becomes a parallelogram by definition by the test. Here I have solved some book questions for exercise 12 to 15 for your reference using the concept of slope. This will be helpful for you for solving the questions using distance and slope formulas. So please check your answers and let me know in the comment section, did you find the video useful? And if you did, give it a big thumbs up, like, share and subscribe to my channel, and see you in my next video. Bye students.